hopefully you didn't need any help on this, but if you did, here it is. And if you didn't, hopefully you are checking all of your answers and looking for those gold nuggets, is what I call them, right? If you find a mistake on your paper, that's like finding a gold nugget. Why? Because it's valuable. Okay, so let's look for it. We already did that first problem, 6-10. Remember, we ended up, I think we had 12 pieces of licorice, right? And there's 6, and 6 more is 12. I made them, if you can see the graph paper, 5 units long each to make it easier since we were dividing with 5 people. So you saw that each person, 1, 2, 3, 4, 5 people got 2 full pieces of licorice. And then these last 2 pieces, we gave them 2/5 each, right? 1 2/5, right? And 2/5 for that person, 2/5 for that person, that one and that one. And then these last fifths on those 2 pieces, put those together for that 5th person. So everybody got 2 and 2/5. All right. On 6-11, we were rounding, and I helped you by identifying the place you're going to round to. And we reviewed real quick the steps on rounding. Remember that PV with a line under it? That means underline the place value. Once you do that, your choice for answers is limited to 2. Okay? Either that 9 stays the same or it goes up by 1. Either that 5 stays the same or it goes up by 1. It never goes up by 2. And it never goes down. That 5 will never go to a 4. That 9 will never go to an 8. That 8 will never go to a 7. It either stays the same or goes up by 1. Everything to the right of what I underline becomes a 0. And if it's to the right of an underline and that becomes a 0 after a decimal, you can chop it off, right? You don't need it anymore. Everything to the left ends up staying the same with one small exception. And you're going to see that exception here because we have that exception happening right here in that first one, right? So that 9 is either going to stay the same or go up by 1. Everything to the right becomes a 0. So I know this is a 0. And since this is after a decimal, I don't need it anymore. So what happens to the 9? Well, what determines that is I look to the right. Look to the right. So I usually draw the little arrow to the right on each of these. It only takes a second. It totally is showing my work and letting me know what I did when I go looking at it later. Now, what do I look at when I look to the right? I'm checking to see, is it a 5 or bigger? If it is 5 or bigger, then I'm going to round the number I underline up by 1. That's an 8. That's way bigger than 5. So that 9 becomes a 10, which means I'm going to carry, right? So that becomes, I carry that. So that's 20 with a 0. So this, when rounded, 198 and 59 when rounded to the nearest tens place, rounds to 200. Now, it will also, if I round it to the nearest hundreds place, round to 200. So that's my answer, 200. I don't need the 0.00. So I'm going to leave it alone. Here, this is either going to stay a 5 or turn into a 6. Everything to the left is staying the same. So this 5, 4, 6, 2, 9, 5, those are all staying the same no matter what. And now this is either going to be a 5 or up by 1, a 6. Since that is only a 4, that 5 stays. So that's what I rounded to. 5,462 and, remember the decimals where you say and, 955 thousandths. Okay, and if I rounded to the thousandths place, I should end at the thousandths place. Okay, tenths, the 8 is in the tenths place. There's a 2 next to it. The 724 is going to stay the same, right? Now, what happens to the 8? Does it stay the same or does it get bigger? Well, that's only a 2, so it stays the same. 724 and 8 tenths. This one's rounded to the ones place. When I look to the right, that's only a 3, so the 1 stays the same. We're going to say that's 851. Okay, and remember, you don't put equal. You can use that if you want to say it's about. The squiggly equal sign means it's about. Okay, we use that when we're estimating or rounding a lot. Okay, on to the next one. How many fourths are in 1/2? Well, 1/4 and 1/2. When I draw a half, I want to know how many fourths. Well, let's make fourths. Looks like there's 2/4 in 1/2. How many sixths in 2/3? Well, when I draw 2/3, graph paper helps on this, huh? Right, that's 2/3. And I want to see how many sixths are in there. 1, 2, 3, 4. How many fourths and 6/8? Yeah, those are eighths. And there are 6/8. How many 1/4ths are in that? Well, let's get another color pen here, and you can see this is 1/4. That's another fourth, makes a half. Another fourth makes 3/4, and another fourth. And it looks like there's 1, 2, 3 fourths in 6/8. And last one on this page, how many halves are in 3 and 5/10? 3 and 5/10. So let's go ahead and make each whole. I'm having it be 10 boxes. Okay, so this is 3 and 5/10. 1, 2, 3, and 5/10 is the same as how much? Can you guys see that? That's 1/2, huh? Now, how many halves are in that? Well, let's divide each one in half. 2, 4, 6. Looks like 7. There are 7 halves in 3 and 5/10. Okay, hopefully that helps you. Leading ourselves to learn how to divide fractions here. Okay, 14/28. Where is that going to be on my number line? Well, let's just go ahead and make a half and make a fourth. Oops. 1/4. Halfway between a half and a whole is 3/4. Okay, then I can kind of estimate. Now, 14 is exactly 1/2. So I'm going to put 14/28 right here. Okay, 75 hundredths is the same as 3/4. So I'm going to put 75 hundredths right on that line. All right, so far so easy. Now, 1/3, I would have to divide this into third. Now, 1/3 as a penny or as a decimal, remember you divide the bottom into the top and it won't fit. So you add a decimal and add zeros and realize that 3 goes into 10 3 times. 3 times 3 is 9. I get a remainder, so I add a 0. 3 goes into 10 3 times. 3 times 3 is 9. Didn't I just say that? I get a remainder, so I add a 0. Will that ever end? No. So 0.33. So this is 0.25. This is 50. 0.33. I'm going to say it's right around here and say this is my 1/3. And I can put 0.3 with a line over underneath because I'm sort of identifying with something else to help me. Okay, 4/7. 3.5 sevenths is a half. So that's going to be a little bit more than a half. Let's put our 4/7 right here. Okay. All right. Let's go to the next one. And the next one talked about some ratios with that we want to make it into a proportion. And the easiest way to do that is to make it a rate. Remember, a ratio is comparing two numbers, sometimes more. Comparing numbers. A rate is a special ratio. where the second number is 1. Okay, so if I have 6 rabbits to 24 daisies, okay, that would be 24 daisies to 6 rabbits. And either way, what I'm doing is I'm simplifying. 6 goes into 24. Okay, so 6 goes into 6 once and 24 4 times. So the ratio of daisies to rabbits is 4 to 1, or each rabbit is eating 4 daisies. Now, once I have that, I can apply it to as many rubber rabbits as you want. But that's the key, getting it simplified down to 1. And this is easy because 6 goes in to 24. But sometimes, what if the ratio was 5 to 2? Well, if I want to rate, I'm dividing the bottom into the top, right? 2 goes into 2 once. That's going to get me the 1 on the bottom. But 2 goes into 5 2 times. Okay, and I have a remainder. So I'm going to add a decimal, bring it up, add a 0, bring it down. And 2 goes into 10. 5. So the ratio here is 2.5 to 1. Okay, 2.5 to 1. Okay, so every 1 is going to be 2.5. Okay, sometimes it's like that, and that's okay. Okay, you want to rate. Okay, and then you could change it. So for every 1 rabbit, 4 daisies are going to get eaten. So if there's 4 rabbits, how many daisies will get eaten? Well, 4 times 4, right? If my ratio of rabbits to daisies is 4 to 1, and I got 4 rabbits, okay, then I'm going to go, rabbits to daisies is 1 to 4, and I have 4 rabbits, I got to go 1 times, I got the 4 times that and 4 times that. So that's the same as 4 to 16. So 16 is how many daisies will get eaten. Okay. All right. Hopefully you had an easy time on this. And if you found some wrong answers, remember that's like finding gold nuggets. Right? Don't feel bad. Feel good. Right? Find it on the homework. You don't want to find it on the test.